Okay, so today we're going to do adding and subtracting matrices and also multiplying matrices by a scalar. Before we get started, we want to go over some vocabulary first. So in box 1, it talks about what a matrix is. All right, so a matrix is an array of numbers. So it's basically two brackets, all right, that host a bunch of numbers. So a matrix is an array of numbers. First vocabulary word. All right, this particular matrix, okay, is a matrix that has 2 rows and 3 columns. So rows go left to right, columns go up and down. All right, so if you think about rows in an auditorium, rows in a theater, the rows are running left to right. If you think about columns on a building, columns go up and down. All right, so let's take a look at box 2. It says a matrix is usually named by a capital letter. All right, so you can have multiple matrices, all right, but each matrix is usually different. All right, and each matrix will have its own capital letter. It'll be named by its own capital letter. This particular matrix has how many rows and how many columns? So this particular matrix has 1, 2, 3 rows. There are 3 3 rows that go left to right. So there are 3 rows. All right, so how many columns? I have 1, 2. All right, so I have 2 sets of numbers that go up and down. So that means there are 2 columns. All right, let's take a look at box 3. So box 3 says the number or entries in the matrix are called the elements. All right, so each matrix is made up of elements. All right, so the elements are the individual numbers that are inside of the matrix. Those are called elements. So if we look at box 2, well, we have matrix A equals 4, -7, 5, 0, 6, and 8. Those individual numbers like 4, -7, 5, 0, etc., those are considered your elements. All right, each element can be identified by using notation like A, 1, 2. All right, so the first number is going to be the row that element is on. The second number is the column. All right, so the element would be in the first row because the first number here is a 1. All right, so that would be in the first row. The second number is a 2. So that means it would be on the second column. All right, so for number 4, it says identify the following. All right, so what would element A, 1, 2 be? All right, so let's number our rows. This would be row 1. This would be row 2. This would be row 3. This would be column 1. This would be column 2. All right, so the first row, second element, first row, second column would be -7. All right, A, 2, 3. So that would be the second row, third column. Well, I don't have a third column. Okay, so because I do not have a third column, that means it does not exist, or you can say no solution. All right, A3, 2. So the third row, the second column. This is the third row, 6 and 8. And then the second column would be right here. So that means 8. All right, and then I'll give you a few seconds. You should be able to do the last one on your own. So you try the last one. I'll give you a few seconds. Press pause if you need to. All right, box 5. All right, so they give us the matrix B equals 7, -9, 12, 5, 1, 0, -4, 6. Which position are the following values in matrix B? So for -4, if I look at -4, let's number our rows and columns. All right, so this would be the first row. This would be the second column. This would be the first row. It's the first column. This would be the second column, third column, fourth column. All right, so -4 is right here. All right, so this would be row 2. So 2 would be the first number, and column 3. So 3 would be my second number. All right, so let's do another one. All right, so number 12. So number 12 is right here. All right, so 12 would be on the first row. Okay, so that means I would have B, and the lowercase letter corresponds with the name of the matrix. All right, so B, and then the row was 1. All right, and then the column is 3. So B, 13. All right, so for number 5. I'll do it in green. All right, so 5. All right, so number 5 is, of course, going to be lowercase b, because this is matrix B that I'm talking about. It is on the first row. All right, and it is in the fourth column, so it would be B14. All right, and then I'll let you try 0 on your own. All right, so I'll give you about 30 seconds to let you do, to name the element position for 0. Press pause if you need to. Okay, next vocabulary word is going to be order. All right, so we're in box 6 down here in the corner. So order is going to be the size or the dimension of a matrix. So a matrix is written as M by N, not M times N. That's the X by. So it's almost like we're measuring kind of like area, feet by inches kind of thing. All right, so M by N, where M is the number of rows and N is the number of columns. So again, rows come before columns. Rows first, columns second. All right, so box 7 gives us the actual matrices. So we have matrix F, G, H, K, and J. All right, and then box 8 wants us to find the order of those matrices. All right, so if I look at F, all right, F has 1, 2 rows and 1, 2 columns. So 2 rows by 2 columns. Okay, that would be the order, the size, the dimension of matrix F. All right, so let's look at G. All right, so again, rows 1, 2, 3. All right, so there are 3 rows. All right, and there is 1 column. So that means it's a 3 by 1 matrix. All right, let's look at H. H has 1 row, 1 column. So it is a 1 by 1. All right, and then look at J. So notice J is all the way down here at the bottom. So J has 1 row. All right, so we know 1 is going to go in the front. By, and then there are 1, 2, 3, 4 columns. So it is a 1 by 4. All right, so here is K. And I'm going to let you try K on your own. So take a few seconds to try K on your own. Okay, press pause if you need to. I'm moving on. Next page. So let's talk about equal matrices. So 2 matrices are equal if they have the same order. Let's get my pen. It's right in blue. All right, so if they have the same order and the corresponding elements are equal. All right, so in order for two matrices to be equal, they have to have the same order and the corresponding elements have to be equal. So if L equals P, L will equal P if, so let's make sure we pair with the corresponding element. So remember, corresponding means the same position. All right, so 1 on L is in the same position as 1 on P. All right, -9 is in the same position as -9. X is in the same position as 3. And 8 is in the same position as 8. All right, so corresponding, those two colors, so here and here, have to match and have to be the same number. So 1, of course, equals 1. -9 equals -9. 8 equals 8. So if I want these two matrices to be equal, X has to equal 3. All right, so take a look at number 10. It says solve for X and Y. All right, so same thing like we just did. We want to make sure the corresponding elements are equal. So -5, I'm sorry, not -5, 0.5 has to equal 0.5. -3y has to equal -3. .5x has to equal 5. And 4 has to equal 4. All right, well, we already know 0.5 equals 0.5 because they're the same exact number. We also know 4 is equal to 4, same exact number. All right, but we need to address the ones that have variables. All right, so -3y has to equal -3. So what I would do is set them equal to each other. -3y equals -3. All right, and then once I set it up, all I do is solve for the variable. So I would do that by dividing by -3 on both sides. Okay, and then y equals 1. Okay, so half the problem is done. Solve for y. I did it. All right, so now I need to solve for x. That was yellow. All right, so 0.5x has to equal 0.5. So 0.5x equals 5. All right, so again, solving for x, so I would divide by 0.5 on both sides. All right, that will cancel out. And x equals 10. 5 divided by 0.5 is 10. And then I'm done. All right, so that is equal matrices. All right, so let's talk about adding and subtracting matrices. It says to add two matrices, add the numbers in the matching positions. All right, so instead of saying matching positions, I want to use the term corresponding. So we want to add or subtract the numbers, the elements that are in corresponding positions. So notice here I have it circled. 6 corresponds to -2. So 6 plus -2 is going to be 4. All right, so -3 and 8 are in the same position. So -3 plus 8 is going to be 5. All right, 9 and 5. All right, so 9 plus 5 is going to be 14. And then last but not least, you have 0 and 4 that correspond. So 0 plus 4 is 4. Okay, and that works the same thing when you are subtracting. Okay, so you subtract the elements that are corresponding. So 9 minus 1 is going to be 8. 4 minus -7, so minus a negative, that becomes plus. So that becomes 4 plus 7, which is 11. So when subtracting, please make sure you pay attention to your signs. All right, -4 minus -9. So again, minus a negative, that becomes plus. So -4 plus 9 becomes 5. All right, 8 minus 0 is 8. 12 minus 3 is 9. And 0 minus -11. So again, minus a negative becomes plus. So 0 plus 11 is 11. All right, so please pay attention to the note down here at the bottom. It says the matrices must have the same order. So if you want to add and subtract matrices, they have to have the same order. They have to have the same dimensions. If they do not have the same dimensions, then it is no solution. All right, so for example, if I try to do F plus G, so notice F is a 3 by 1 matrix. Okay, G is a 3 by 3 matrix. All right, the order is not the same, so therefore I can't add them. They don't have the same corresponding elements. Okay, so this has 2 extra columns, so I wouldn't be able to add them. However, A plus B, D minus G, and C plus H are available. All right, so you can do those. All right, so I would like you to do those on your own, okay, using the examples of 11 and 12 that I just went through. All right, so press pause to give yourself a minute to complete them, and then I will post it. And I forgot to write the answer. This would be no solution. All right, and you will have the answers to number 14 posted in Google Classroom. Okay, all right, last page, multiplying by a constant. Multiplying by a constant is basically the same thing as distributive property. All right, so when a matrix is multiplied by a real number called a scalar, all right, so this is another vocabulary word. All right, so scalar is a vocabulary word. All right, so that means real number or constant. Each element is multiplied by the scalar. The result is another matrix of the same order. All right, so for example, 3 times -7 would give me -21. All right, 3 times 1 would give me 3. So 3 times 9 would be 27. 3 times 3 would actually be 9 and not 0. I think messed up on that one. All right, 3 times 0 would be 0. And yellow. 3 times 6 would be 18. All right, so basically all you are doing is distributive property. All right, you take what's on the outside and you multiply it by everything on the inside. All right, so distributive property. So 3 times -7 would give me -21. 3 times 1, 3. 3 times 9, 27. 3 times 3, 9. 3 times 0, 0. 3 times 6, 18. All right, so now that you know how to multiply by a constant, we're going to put that to work to do some order of operations. All right, so I have 2 times the matrix A. So this one is simple multiplication. So I have 2 times 6, 0, -3, and 5. This is a negative 3, excuse me. All right, so again, like I said, we are just doing multiplication. So 2 times 6 would be 12. 2 times 0 would be 0. And I'm getting these matrices from over here in this corner. They give you A through K. So that's where I'm pulling these matrices from. All right, 2 times negative 3 is negative 6. And then 2 times 5 is 10. And this is a 0, by the way. Boom. Okay, that would be my final answer. All right, so let's look at number 2. It says A plus 1/2 B. So order of operations. A would be 6. I'm going to substitute first. 6, 0, negative 3, and 5. All right, so that's matrix A plus 1/2 matrix B. So matrix B is going to be 4, 0, 8, 24. Okay, so order of operations tells me to multiply before I add or subtract. So I'm going to do 1/2 times the matrix B first. So that means matrix A will stay the same. It will not change. Okay, but first I'm going to go ahead and multiply 1/2 times matrix B. So 1/2 times 4 is 2. All right, 1/2 times 0 is 0. 1/2 times 8 is 4. 1/2 times 24 is 12. All right, then after I do my multiplication, now I can add. All right, so I add the corresponding elements. So 6 plus 2 is 8. 0 plus 0 is 0. Negative 3 plus 4 is positive 1. And then 5 plus 12 is 17. And then that would be my final answer. Okay, so the rest of them in 18, 19, 17, 18, and 19 are exactly the same. All right, you follow order of operations. You substitute your matrices from the matrices that are over here in this corner. Over here. Okay, and then I want you to try 18, 19, 17, 18, and 19 on your own. All right, again, your answers to these questions will be posted in Google Classroom. All right, try them on your own first before you go back and look at the answers. All right, if you have any questions, you may text me and I will be happy to respond. All right, your work is also posted in Google Classroom. It is a computer assignment. You will find the directions inside of the Google Slides. Again, if you have any questions, you may text me. Thank you so much for watching my video.